Inverting amplifier is one of the most commonly used amplifier circuit. And as you can see, this is the circuit of inverting amplifier. The input signal is provided at the inverting input of your op-amp, and that's why it is called inverting amplifier. Well, this is one of the reasons it's called inverting amplifier, but the main reason of the amplifier being called inverting amplifier is, as you will see, the output voltage phase is opposite as compared to the input voltage phase. So when input, if it's a sinusoidal signal, let's say when input is peak, maximum peak, the output is minimum peak. So the phase of output is 180 degrees opposite with respect to the phase of input, and that's why it's called inverting amplifier, as output is inverted as compared to the input. But in general, to recognize if the amplifier is inverted or not, the input is given to the inverting input of the amplifier. Okay, so how do you do the analysis of this circuit? Very simple. The analysis is given, of course, here, but let me tell you. So as we discussed, the positive input or the non-inverting input is grounded, so you have a 0 volt over here. And since the inverting input and non-inverting input has the same voltage, that means you have a 0 volt over here as well, as you can see here. This is called virtual ground. It is not physical ground because it's not connected physically to the ground, but it has the 0 volt based on the condition that V positive is equal to V negative, so it's called virtual ground. So if you do the analysis on this circuit, if you apply KCL at virtual ground, you have I1 equals IF, or I input equals IF, or I1 equals IF. So apply Ohm's law, V input minus 0 over R input, V input minus 0 over R input is equal to IF, which is 0 minus V output over RF. 0 minus V output over RF. So what are you going to get? The output voltage will be equal to negative RF over R input times V input. So that's going to be the expression for the output voltage. So this, look at this negative sign. The output is inverted with respect to input because of this negative sign. If, again, as I said, if input is a sinusoidal waveform and it has a peak value, the output will have the negative peak at that time. And this is called closed loop gain of the inverting amplifier. We call it ACL, closed loop gain of the inverting amplifier. So you can set the gain to any value based on what is the value of the feedback resistor. This is called the feedback loop, and this is the we call it input resistor, or the resistor R1, whatever you want to call it, but this is called the feedback loop, and this is the feedback resistor RF, and this is R input or R1. So the ratio between RF and I is the gain, closed loop gain of the amplifier. Remember, open loop gain is still A, but we are not using A in the equation. Observe, there is no A here, right? So you can create whatever gain you want from the circuit based on the values of RF and R input. And a very commonly used amplifier again. This is the analysis that I showed you. Okay, next, there are some also thing, what is the input resistance of the amplifier? Input resistance is measured as the ratio between the input voltage and input current. So if you look at the circuit, input voltage is here, input current is I input. So input resistance of this circuit, V input over I input, is this, right? Using Ohm's law, because as I showed you, I input is V input over Ri, right? So R input is going to be V input over I input. So that's considered the input resistance of the amplifier. This is a diagram that shows you that if this is the input of the amplifier and the gain of the amplifier is assumed to be 2, closed loop gain assumed to be 2, then the output input peak value is 1, the output peak value will be 2, and the phase of the output will be opposite with respect to input. So when input is high, output will be low, and vice versa. The next is non-inverting amplifier. And like the inverting amplifier, non-inverting amplifier, the phase of the output is the same as phase of the input. So it's not opposite of the phase of the input. And that's why it's called non-inverting amplifier. The way you recognize non-inverting amplifier is input is connected to the non-inverting input terminal of the amplifier, op amp. So again, if you do the analysis, which I have done right there, but let me just go ahead and show you. Basically, whatever voltage you have here, which is V input, the same voltage is gonna appear here because the V positive is equal to V negative. So at V negative, we also have V input. And you apply the KCL again at the non-inverting input, and you apply KCL, you're gonna get again IF is equal to I input or I1, whatever is gonna call it. IF is V out minus V input over RF, V out minus V input over RF, and I1 is V input minus 0 over Rn, V input minus 0 over R input or R1, whatever is that, right? And from that you can figure out what is the relationship between V output and V input, which is given over here, of course. So the closed loop gain for this circuit, V output over V input, is 1 plus RF over R input, right? So there is no negative sign here. A special case of non-inverting amplifier is voltage follower. This is a circuit, and this is a circuit or this is a circuit. Basically, you have the same resistor in the feedback loop as connected to your positive input, and input is given over here, right here. This is the input. It is not shown here, but the input is applied over here. So the output is going to be what? Output is going to be exactly equal to the input. V input is here, of course. V input is going to appear at the negative terminal as well, and negative terminal is connected to the output. So simply V output will be equal to V input. You will ask what is the purpose of this amplifier if the output is equal to input. Well, there's a good purpose of this amplifier, as if you want to isolate the load that is connected at the output. So if you're connecting a load over here, if you isolate this load from the source, you can use this amplifier. Why do I want to isolate the load and the source? Because sometime when you connect the load, it can load down the source and the source voltage goes down. So if you have this type of amplifier, then the source voltage is not going to go down with whatever type of load you are connecting at the output of the amplifier. So output of the amplifier, it will still see the same input voltage, but it's not going to load down the input voltage. Okay, it's given over here. Alright, there are some examples given here, and I think these are very detailed examples, so you can go over them. I have explained everything in these examples in good detail, so go over them, and again, if there is something that you will not understand, then we're going to discuss that.